Hi, hello everyone. Good evening. So, welcome to another amazing and super exciting session of Super Sprint Series 2.0. And this is your Ameer sir, Master Teacher of Physics at Vedantu. Now, everyone, quickly tell me how are you all doing? Obviously, hi there, Niga. Good evening. So for me, it was a super great day. I was too happy. I don't know, no reasons was there, but still I was super happy. What about you all? Was it an amazing day? Were you happy? Was it a boring? Okay, so hi there, Niga. You were fine. So seems like it was a very normal day for you, and I hope everyone's revisions are happening in the right way. Okay. So hi Kaushika, good evening, good evening, good evening. Hi Vedika. So we have so many people in the classroom. Happy to see every one of you. So what about the revision plans of everyone? Is it going according to the plan? Is it going according to the timetable? Because you know that in February we are going to meet with the very first JEE mains, right? I'm doing so good, Kaushika. Thank you so much. I hope it is visible from my face, because I don't know, because I have that smiling face maybe. So anyway, I'm happy. I'm all good, I'm all good, I'm all good. Okay, I love that smiley, Kaushika. Hi, Tornado. Welcome to the class. And yes, I'm going to think that everyone is doing so good and fine. And I'm going to be super happy once you tell me that you have completed the revision of all the chapters we did till now. Which means if we look at the timetable, we have completed the revision of the chapters electric field, then potential, capacitors, and current electricity. So tell me, did you all completed the revision of these parts? Tell me that. I'm gonna be super happy once I get to know that. You are a fan of physics? Okay, then let's try to make this session so awesome by learning many concepts of physics, right? Okay, yes. You finished? That's good, Kaushika. Yo, okay, half of this. Okay, try to complete this, okay? Very good. So here we are with another amazing chapter. Which one it is? Right, with the magnetic effect. You know that a bit of complex equations are there, a bit of complex concepts are there. We'll try to complete most of the topics from this chapter by doing maximum number of questions, right? And one more thing before we start with the session, everyone who is here, okay, move your cursor and click on that red subscribe button now itself. Don't be late, because I think you don't want to miss any of the classes which is coming from the Vedantu channel, Momentum with Vedantu channel, right? And it's going to be a super, let's say it is going to make us also excited to do more and more classes, because it is almost like a compliment once you make a subscription to the channel. Okay, and questions whatever we discuss here, it will be updated before this goes live, this class goes live in the Telegram group. You can come and join and be a part of the Telegram group by clicking on the link which is given here and in the description below. Fine. Okay, and one last thing, we are directly going into the question after this, which means if you are a person who need a personal mentoring or personal attention, if you want to complete all your theory before this JEE exam comes, right? If you want to do a number of questions, and based on all these what you have studied, if you want to write the mock test and analyze how much you have learned, right, and what all are your topics which you are still to learn, right, you can really be a part of the cash course. Okay, actually it costs 10,000 rupees, but I'm giving you a code AMECC. Okay, click on the link, apply the code, and get this for just 8,000 rupees, guys. Just think of 8,000 rupees. It's going to change your future. You are going to have an amazing career and be a part of Vedantu family. Now give me a yo in the chat box, because we are going to start with the very first question, shall we? Because that yo will tell me you all are super excited and super energetic for the very first question to be appearing. Very good. That's good, Tornado. So other than Tornado, is he the only person alive here? Don't we have anyone else who is super active? Yes, there, Niga, we have. Very good. So shall we start? Yes, I think from everyone. Here we go. Now everyone along with me, you can read the questions. I'll stand here. That's better. So we have two short bar magnets of length 1 centimeter. Each have magnetic moments 1.2 and 1 ampere meter square respectively. They are placed on a horizontal table parallel to each other with their north poles pointing toward the south. Okay, don't worry, I'm going to explain the question in detail, just stay with me. They have a common magnetic equator and are separated by a distance of 20 centimeter. The value of the net resultant horizontal magnetic field induction at the midpoint O of the line joining their center is close to the horizontal component of Earth's magnetic field is also given. Now let's discuss, okay, because this is a very big question. Once you read just like that, you are not going to understand anything. That I know that, right? Because I was also a student of 12th standard once, right? So let's discuss. So you have two bar magnets, right? So here we go. Okay, so we are having two bar magnets. This is a north pole, this is a north pole, right? The distance between them is 20 centimeter. In between we have a point O, okay, which is at the equatorial point of both the magnets. Now if we draw the magnetic field lines of both the magnets, it's going to be like this, right? Moving from the north towards the south. It starts moving from the north towards the south, which means at the point O, the direction of magnetic field produced by both the magnets are the same. Okay, that part is done. Now these two magnets are kept pointing towards, let's say this is our Earth, right, and towards the south pole of the geographical Earth, right? Okay, now we know that the Earth is also acting like a magnet. I hope you remember, in such a way that the magnetic field produced by the Earth makes it feel like there is a bar magnet kept well inside. Okay, actually there is no bar magnet, but the field lines produced by the Earth make it feel like a bar magnet is kept inside, in such a way that the north pole of the bar magnet is kept almost close to the south of the geography or south pole of the Earth, right? This is how it is existing. Now if we find out the magnetic field lines of the Earth, it will also be start moving from the north toward the south, which means the magnetic field lines produced by two of the magnets and the Earth's magnetic field all are in the same direction at the point O. So the total value for magnetic field, let me write it here, right? The total value of magnetic field is magnetic field produced by the first magnet plus magnetic field produced by the second magnet plus horizontal component of Earth's magnetic field. What is horizontal component? I hope everyone knows, right? The component of the Earth's magnetic field acting along the horizontal surface of the Earth. The vertical component, here we don't need the calculation because we are finding out the net value of magnetic field on the horizontal surface of the Earth. Till this clear? Now let's start finding out. This is directly given, right? The horizontal component of Earth's magnetic field, it's directly given. You want to find out the magnetic field produced by both the magnets. Now considering this magnet, the point O is an equatorial point, right? A point on the perpendicular bisector. If I draw a perpendicular bisector to the bar magnet, the point O is that kind of a point, which is at a distance of 10 centimeter or 0.1 meters. What's the formula? Who is going to tell me? Tornado, Dharnika, Kaushika, Vedika. Who is going to tell me the formula for that? The value for magnetic field, where can I write? Yes, the value for magnetic field is given by the formula of mu naught divided by 4 pi m divided by r cube. Right? The value for the magnetic field is mu naught divided by 4 pi m divided by r cube. Yes or no? Yes. So let's start substituting the values. Mu naught by 4 pi is 10 power minus 7 m. The magnetic dipole moment, how much is? For 1 it is 1.2. So 1.2 divided by r. The distance to the point from the magnet, it's 10 centimeter or 0.1, which is 10 power minus 1. So cube of 10 power minus 1 is 10 power minus 3. So this will come around as 1.2 into 10 power minus 4 Tesla. This is B1. What about B2? Same formula, the only difference is in the magnetic dipole moment, as you can see. So I'm just writing it quickly. Mu naught by 4 pi m divided by r cube here, that is 10 power minus 7. M here is 1 by 10 power minus 3. Okay, 0.1 the whole cube, right? Good. Now you can say that this is 1 into 10 power minus 4. So B1 is equal to 1.2 into 10 power minus 4. B2 is equal to 1 into 10 power minus 4. So B1 plus B2 is equal to 2.2 into 10 power minus 4 plus horizontal component is 3.6 into 10 power minus 5. In 10 power minus 4, it is 3.36 into 10 power minus 4. So this will come around as 2.56 into 10 power minus 4 Tesla, or another unit of magnetic field is Weber per meter square. So we can go with the option B as our answer. Is it clear? Everyone? Is it super clear? Everyone with a smiling face? Very good, because you have to be smiling. You have completed most of the theory and one question from the chapter of magnetic effect. That is simply awesome. Very good, Dharnika. So moving to the next question. Now listen here. Okay. Now this looks like a very big question. So instead of reading the question, I'll be explaining. Listen, right? So at the point O, we have an infinitely long current carrying conductor. Okay, which is projected outside. So a current carrying conductor is coming outside, as you can see. Okay, now we have a loop ABCD also, where the current is I, and in this infinitely long current carrying conductor, the current is I1. Okay, now the angle, it is 30 degree. Okay, so the AB, what all things are, the radius of this BC is given as B, the radius of this AD part to the point O, that is given as A. All the things are given. So the questions, let us start finding out. The first question is, the force on AB and DC are 0. So from where the force is coming? That should be the first question which should be coming to your mind, right? So the forces that can come on AD and BC, which one is it? It's AB and BC, AD and DC, right? Okay, those are current carrying conductors. Current carrying conductors will be experiencing forces in the presence of an external magnetic field. Now, is there any external magnetic field? The answer is yes. From where an external magnetic field is there to this current carrying loop. Can you see another current carrying conductor I1 where the current is popping out? Yes, so the current carrying conductors will be producing the magnetic field. How will you find the direction of the magnetic field produced by the current carrying conductor? Everyone, take out your right hand. Everyone, take your right hand. Keep your thumb in the direction of the current. Now the current is coming out, as you can see. Curl your fingers like this. Okay, so the direction of the curled fingers will give you the direction of the magnetic field. So you can see the concentric circles are the direction of what? The concentric circles are the direction of magnetic field, as you can see. 1 minute. Okay, so very good. So Dharnika, you are totally participating in the classroom. That's really amazing. Happy to see that. Now, as we have said, the magnetic field is in concentric circles like this. Okay, so we have magnetic field, okay, according to the right hand thumb rule, right? And the question is regarding the force experienced by AB and DC. Now, if these are concentric circles, this AB will be perpendicular because ABs are the lines starting from the point O. So those are acting as radius, obviously. Now, the force experienced by current carrying conductor is I, L, B sine of theta, the angle between the current carrying conductor and the magnetic field, right? So there is a current in the AB conductor, right? Yes, it is having a length. The magnetic field is this. The angle is 90. Yes, it will be having a force. So the first one, the force on AB and DC are 0. That's a wrong statement. Okay, next one. The force on AD and BC are 0. That's a right option. Do you know why? Look, along AD and along BC, right? The angle made by the magnetic action, which means here the theta is equal to 0, here the theta is equal to 180. Whatever, sine of 0 and sine of 180, both are what? 0. So the force experienced is equal to how much? Simply 0. So yes, the second option is correct. Now, we are not trying to do the actual mathematics of C and D, but let's try to understand the magnitude of the net force. So, we know that AD and BC force is 0. So, the only force experienced is on AB and DC. Now, you all know how to find the direction of the force experienced by the current carrying conductors, right? Fleming's left hand rule. Okay, so you have the index finger where it has to be pointed in the direction of the magnetic field. It is upward, as you can see, right? And the middle finger should be in the direction of the current, so the force will be in the upward direction, as you can see, right? So this is magnetic field in this direction, current is upwards, right? So the force is out of the plane. Okay, now if you look at DC, which is exactly similar like AB, but the current is in the opposite direction. Magnetic field is this, current is opposite, the force is down. So you know that AB and DC are completely similar. Similar means it is equidistant from the current carrying conductor O. So the force that it produced will be the same, and the force direction is simply going to be opposite. The magnitude is going to be the same because it is existing in a symmetrical fashion with the current carrying conductor I1. Okay, so the magnitude is same, it's coming as opposite, net force is going to come as 0. So option C and D are simply wrong option. So which option we can go for? We can simply go with the option B as our answer. Is it clear? Everyone in the classroom without having any doubts? So yes, I think we can simply go for the very next quiz. Okay, so yes, we are jumping to the next question. A potential difference of 600 volt is applied. Very good, Arnika, amazing. Okay, whatever doubts you have, please let me know, we'll clear it out. Now there is a potential difference of 600 volt between this parallel plate capacitor, right? And there is a magnetic field is also existing. Okay, a magnetic field is also there. The separation between the plate, the distance between the plate is 3 millimeter. An electron is projected, as you can see. Electron is negatively charged, you have to know that. Now upward parallel to the plates with a velocity of 2 into 10 power 6 moves undeflected between the magnitude and direction of the magnetic field. Okay, how this question can be done? Listen to me very carefully. As you can see, it's an electron which is moving up. Right, it's an electron which moves up, which means charge of minus E is moving up. So this electron has a tendency to be deflected in the opposite direction of electric field. We know that electric field always exists from positive towards a negative, but the negative charge will have a tendency to move towards the positive charge or opposite to the electric field. Right, so the force experienced by this electrons, okay, because of the electric field is equal to charge into electric field, but it says that the charge has to move undeflected. So there should be something in order to provide a force in the opposite direction. Okay, who can provide a force? There is told that a magnetic field is there, so this magnetic field has to provide an equal amount of opposite force. Right, and the force experienced by a charge in a magnetic field is QEB. So the QEB should be simply towards what direction? It should be towards the right direction, right? Okay, so the magnitude of a force experienced in a magnetic field should be QEB, and that should be equal to QE. So that the charge, which is an electron, will be moving without any deflection. The question is to find out what is the question, the magnetic field direction and the magnitude. We'll find out the direction later. Let's start with the magnitude of magnetic field. QQ is cancelled, right? And what we have is magnetic field is equal to E divided by velocity. Now electric field, how will you express in terms of potential difference? It is a potential difference divided by distance between the plates divided by velocity. No doubts, I suppose, right? No doubts, anyone? Okay, now what do we have here? The potential difference, let's start substituting. What do we have? It's 600, so that is 6 into 10 power 2 divided by the distance between them is how much? 3 millimeters. That's 3 into 10 power minus 3. And velocity is, what's the velocity given? Oh, it's 2 into 10 power 6. So it's 2 into 10 power 6, right? So how much we can go with it? So this is going to be 3 2s are 6. 6, this will cancel. This is 10 power 5 by 10 power 6. So it's 0.1. So the value for magnetic field is 0.1. Now the direction is the question, right? How can we find out the direction in which magnetic field is existing? Now the force experienced by a negative charge should be towards what direction? It should be towards the right, which means we know that the force given by Fleming's right hand rule is the force experienced by a positive charge. So if the negative charge want to experience a force towards right, so the same amount of positive charge should be experiencing a force towards the left. Why we are doing in this manner? Because Fleming's left hand rule directly gives the direction of force experienced by the positive charge, right? Okay, now so the force experienced by the positive charge should be towards left. So take out the left hand. Okay, so extend your fingers all in mutually perpendicular direction. So the thumb should be towards left, which shows which shows the direction of the force it experiences, right? And then we have this index finger should be pointed in which direction? The index finger should be pointed in the direction and the velocity is towards up, right? So the velocity should be towards up. So it simply says, what you can find out? It simply says the magnetic field should be upward, but as it is a negative charge, it should be downward direction. You just have to take the opposite direction. That's it. So I hope it is clear till this part. We can go with the option A as our answer. Hi Neha, good evening. Is it clear till this part, everyone? Any doubts? If you have, you can ask me. No, yes? Okay, so moving on to the next question, where it is. So two parallel long wires carries current I1 and I2. When currents are in the same direction, the magnetic field midway between the plate is 10 microtesla. Okay, and when the direction of I2 is reversed, it becomes 40 microtesla, the ratio of I1 by I2. I'll explain. Listen, we have two current carrying conductors. Okay, so one is I1 upwards and I2 is also upward. Let's take a middle point where the distance from both is R. So when both the currents are in the upward, right? So let's try to find out the magnetic field produced by both the current carrying conductors. How? Right hand rule. So keep your thumb in the upward direction, right, as you have done. Now curl your fingers. So the fingers at this point, let's call this as point O, right? So the curl fingers show the magnetic field is inside. So the B1 is inside in this position, right? Cross means inside. What about the magnetic field produced by the second current carrying conductor? Keep your thumb up, curl your fingers, the fingers show outwards, right? So the magnetic field of B2 is outward, which means the net magnetic field is equal to B1 minus B2. And this is given as how much? 10 microtesla in the first case. And what is the formula for magnetic field produced by a current carrying conductor of infinite length? Okay, tell me that, Niga and Neha. It is given by mu naught divided by 2 pi, mu naught by 2 pi, I1 divided by R minus mu naught by 2 pi, I2 by R. If we take mu naught by 2 pi R as common, it is going to be I1 minus I2. That is 10 microtesla, right? Okay. Now in the second case, when the current are in the opposite direction, I1 and I2, okay, you know that the magnetic field produced by current I1 is inside, okay, and the magnetic field produced by I2 is also inside. So when the direction changes, both the magnetic field, so both the current magnetic field produced by the current carrying conductors are in the same direction. You can easily find out like the way I said by using the right hand thumb rule. So the net value for magnetic field is B1 plus B2. So I'm not going to write the same thing. So here instead of minus, it's going to be the plus. That's the only difference. So it is mu naught divided by 2 pi R I1 plus I2. And this value is given as 40 microtesla. This is the first equation and this is the second equation. Any doubt till this part? No, I suppose. So now what we are going to do is, okay, Dharnika, tell me, what will we do? You can divide the equation 1 by 2. What happens? Once you divide the equation, 1 is on the left hand side, it is 10 by 40. So 10 divided by 40 is equal to mu naught by 2 pi r. Mu naught by 2 pi r will cancel. It is I1 minus I2 by I1 plus I2. Cross multiplying, cancelling the zeros. I1 plus I2 is equal to 4I1 minus 4I2. Yes. So start rearranging. 4I1 minus I1, that's 3I1. I2, 5I2. So I1 by I2 is equal to 5 by 3. We can go with the option B as our answer. Is it clear till this part? No doubts, I suppose. I hope everyone is having a very smiling face because we learned a lot in today's class. Yes or no? We learned a lot about today's session, right? And the today's topic of magnetic effect. What you have to do is, after the sessions, open your NCERT, whichever parts you are having doubts, get it cleared within half an hour or 1 hour. Okay, don't extend the theoretical because we are very limited with the days. Okay, so try doing maximum number of questions here. Okay, now what I want to tell you is, if you have understood everything, don't hesitate to move your cursor and to hit the like button. You all will be doing it, right? And you can ask your friends also to come and join the classroom, so you can share the link and understand that this class is going on. Ask your friends also to come and join because we're going to make an amazing team here. Okay, and the last part, which is a subscription, I think you really want to do that because you don't want to miss any of the sessions, which are super amazing sessions regarding your 11th and 12th classes are going to happen. So I think you don't want to miss it. So now itself subscribe, you'll get the notification, and it's going to be a super compliment for everything what we are doing for you all. So yes, thank you so much. We're going to meet in the next class. Till we meet next time. Bye, and yes, good night.